So for my project, I needed to build a model to predict the output of a engine, basically a combined cycle power plant, and the electrical energy of the power plant. The data that I received had four different variables, or those are my variables. But I have the ambient temperature, the exhaust vacuum, the ambient pressure, and the relative humidity. And of course, I have the energy output, which is the variable, the dependent that we want to be predicting with the model. Um, of these five columns, the first four are our features, and the last one is our output. Of course, the output needs to be the electrical energy. So PE is my output variable. Before I begin the analysis, I first did a count of the total records, which is 9,568 different rows, out of which I have picked 20% for a test set. That's 1914 records, and I've just simply picked the 1914 from the bottom, and slice that into a test set, which can be seen on the right here, and then from the remaining 7654, I have further divided that into a validation set and a training set. And that's only because before I went into training the model, I did want to have um, a separate set of records just to validate in case I need to play around with the hyperparameters and things like that. Um, so getting right into the next step, which is the feature selection. For my feature selection, basically, I'm sorry for the scroll here. But for the feature selection, what I essentially did was I did build a regression for each feature versus the output that we're trying to predict. And as you can see, this is just one of the plots that I have over here, which is the ambient temperature versus the PE. But I didn't really see a difference between performing a regression using data analysis over here, or plotting a scatter plot. It's literally the same thing. So I just ran the regressions, and as you can see, each of the features versus the output variable. And what I could see is I picked R square, so I've highlighted those. What I found that is AT, which is the ambient temperature, and the exhaust vacuum actually have a better R square than ambient pressure and relative humidity. So for my model 1, I actually chose just the ambient temperature and the vacuum. And for the Model 2, I actually picked the next best one, which is the ambient temperature. The ambient pressure. And that's sort of what I initially anticipated. But then as I really progressed with my models, I actually saw that, and I'll show you later. But Model 3, which is my complete model, has all of the components, and Model 4 has AT, V, and RH. Basically, there's no ambient pressure. And we'll come to that in a bit. I just wanted to play around with some of the models. But if I ran the regression for Model 1, these are the statistics that I saw. So I took the adjusted R square because multiple linear regressions suggested that I should look at that first. So that's around 91%, 91.59, which could be 91.6 if I'm running it after one digit. And then that's the standard error, which I assume is a square, mean squared error. So that was for Model 1, which is basically just the ambient temperature and exhaust volume. My Model 2, again, it's 91.8, not that big of a difference, and then it's 4.87. Again, very close to Model 1, but you do see a slight improvement in Model 2. My Model 3, which I've named here as complete model, is actually the best result that I got, which is 93% and 4.5 in terms of standard error. Um, and of course, I ran Model 4, but Model 4, I really didn't see um, the best performance in Model 4. Um, and when it came to really running the models, I actually picked Model 1 and 2 without running Complete and Model 4 first. So I actually only did validations on Model 1 and 2 first. But then when I did Model 3, which is our complete model, um, I did see that overall this was performing a lot better. The standard error was less. And as you can see, our R square and adjusted R squares both are actually the best in the complete model, which means all of the features being selected. And finally, um, I ran the test data um, on the the final model, which is uh, the model that has all the features, and I actually saw that it's pretty neat. It's pretty um, comparable to the validation statistics and the model comparison statistics that we saw with training the model. So in my analysis, the concluding statement would mean that my output would best be predicted with all the features in it. And the coefficients that turn out to be the best are actually in here. And let me just type it out for you. It's AT, which is ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. So those would be the coefficients and the intercept, which means it's the y equal to mx plus b. Our b is 453, and each of those coefficients would then be multiplied with each of the variables respectively. And that concluded my final model to predict the output of a combined cycle power plant for the project. Thank you.